Okay, so resuming with interpret exponential function constant. There we go. So we have a t here. I wanted it to just be t, and earlier the example had like a number times t, which is not what I wanted. Anyways, so this function represents the change in a quantity over t days. What does the 1.3 reveal about the rate of change of the quantity? So first drop-down menu says decaying or growing. So essentially, is this increasing or decreasing? And that's just dependent on if the 1.3 is bigger than 1, increasing, smaller than 1, decreasing. So 1.3 is bigger than 1, so this is going to be growing. If you have like a 0 point something something, that would be decaying. 0 point something something would be decreasing. 1 point or anything bigger than a 1 would be growing exponentially. All right, to find out what rate, you're going to have to take the 1.3 and subtract 1 from it, because we're wanting to see how much more than 1 is it. So 1.3 minus 1 is 0.3. So 0.3 is our rate as a decimal. So now we must convert the 0.3 into a percentage. And how do we do that? We take your decimal and move it 2 times to the right. And so that gives me 30, which means 30%. Every month, days, whatever, take a look. It says T days. So then you just do every day. Okay. Okay, and then let's do exponential functions basic. Let me clear my annotations because they're bothering me. All right. $6,700 is placed in an account with an annual interest rate of 8%. How much will be in the account after 24 years to nearest cent? So we have to first write an equation, and then we need to plug stuff into that equation. And then when we're plugging it in, we will be using the calculator. So let me write our equation first. When you write an exponential function, you have this kind of format. Y is equal to their start number, and then 1 plus or minus the rate, plus if it's increasing, minus if it's decreasing, and then you kind of raise it to the power of t, the time. Okay, so this is the format that we have for all of these exponential type functions, and let's fill it in. So y is equal to the starting number. How much does this person start with? $6,700 was placed in the account. So you're going to start by putting that $6,700 into the account. That's my start number. And then it has an annual interest rate of 8%. If it's not directly stated, you have to think about the situation. So when you put money in a bank, you're kind of hoping that the bank gives you interest, right? So if it's going to increase the amount. So this is going to be a 1 plus. You're not going to do a 1 minus. You're going to do a 1 plus. Now with this 8% as your rate, you have to convert it into a decimal by taking your current decimal place and moving it twice to the left. So 0.08. And then you're just going to raise it to the power of t. I'm going to rewrite it right here just because I need more space. So we got 6,700, and then 1 plus 0.08 is 1.08. Right, and finally we need to raise it to the power of t. So what is our t value? How much time has passed? 24 years. So I'm going to put a 24 over here. And then we type that exact thing into the calculator. So 6,700, 1.08 to the power of 24. And are there any questions? Or actually, let me read it to you. Sorry, this one, I know the people in the Zoom, I think people in the Zoom can probably see it, but I know people here in person cannot. So I'm just going to write it out. 42485.9109. Okay, so we're rounding this to the nearest cent. Nearest cent means 2 decimal places, because if you think about prices, it's like $4.99, $5.95, or something like that. You got 2 decimal places. So I'm going to cut it off after the 9-1. Since it's a 910, I don't need to change that 1 into anything. It will just stay as a 1. So let me type it in. 42485.91. And I'm not going to type anything after that because this is 2 decimal places. It is the nearest cent already. Let's do another example from another category. All right, so where are we? Okay, exponential functions basic solving. So this one, we're still going to start off by writing an equation. So let me write an equation first. A town has a population of 2,000 and grows at 4.5% every year to the nearest tenth of a year. How long will it be until the population will reach 3,900? So let me write out the equation format. Same thing as before. Start and then 1 plus or minus the rate, and then raise it to the power of t. So let's write it out. So the starting number, town has a population of 2,000. That's your starting. And then it's growing, so I'm going to do a 1 plus, not a minus. I'm going to do a plus because it's growing. I'm going to take that 4.5% and move the decimal 2 times to the left. So it's 0.045. To the power of t. Okay, so let me rewrite this. So 2,000 and then 1.045 to the power of t. So in the last problem, we plugged in something for t because we knew how long it took. They said 24 years, so we plugged in 24. This time, we don't know how long it will be because that's the question. So they're saying, how long will it be until the population will reach 3,900? So this is where we're going to use Desmos. So in Desmos, I'm going to type 2 equations. I'm going to type this first equation, the one that we just wrote, except that instead of a t, I'm going to type the letter x into Desmos because Desmos uses x and y. So in Desmos, I'm going to type our equation with an x, and then I'm going to type a second equation. You see this number 3,900? I'm going to write that as the equation y equals 3,900. So this will be the second equation that I type into Desmos. So I'm going to go ahead and type those in. Y equals 2,000. Oh, I'm not typing. Okay. Y equals 2,000. 1.045 to the power of x. Oh my gosh. I'm not typing this properly. 1.045 to the power of x. There we go. First equation done. Next equation is y equals 3,900. All right, so I typed my 2 equations in there, and I'm like, oh no, I don't see anything. Why don't I see anything? Well, if you look at my numbers, this is like, goes up to 6. Look at this number, 3,900 and 2,000. I need to go up or zoom out until I see the thousands. So that's what I'm going to do. I'm going to zoom out a ton. Okay, there's one of my equations. You can see the 1,000, 1,500. And I'm just going to scoot this up. You can click and drag, okay? Click and drag, and then I see both equations. I see my purple line and my green exponential. And all you need to do is look for their intersection point. It's a little bit hard to see. So I'm just going to zoom in a little bit and click right there. So when you're clicking for the intersection, it's really easy for people to click the y-intercept. But my clue to you is if you see a 0 here, you click the wrong one. So just keep clicking until you get one that's not a 0. If it's too hard, you can zoom in a little bit more, and then you can see that there's going to be the 0. That's the wrong one. You want the one that's not the 0. Okay, so don't use the one with the 0. I want to click and drag this so that maybe you can see it better. Can you see it better over here, maybe? So it's less blocked. No, now it's blocked again. Okay, so this is the point we want. And we just need to round this number, the 15.172. That's the number we want, the 15.172. We are rounding this to the nearest tenth. So that's 1 decimal place. So it's going to be 15.17. The 7 is a big number, so the 1 gets rounded up to a 2. So it's 15.2. 15.2. So I'm going to type 15.2. So this one, 15.2. Okay, and then now we have table to exponential functions. Let me get rid of all my annotations. Okay, find the equation of the exponential function represented by the table below. So once again, you just have, we have this format, y is equal to your starting number times your common ratio to the power of x. So starting number is, actually, I'll keep using red sign. It's your start. And by start, I just mean what is the number that's next to 0? So 0.01. And then let's do B. B is the common ratio. And so to get the common ratio, it's what are you multiplying by every single time? And so sometimes it's more obvious, sometimes it's not. In this case, I would assume for you guys it's not so obvious what the common ratio is, but here's what you do. You just choose any two numbers that are next to each other. Like I could choose these two. I'm just going to choose those two. And I'm going to divide them bottom, divide it by top. So that would be 0.0025 divided by 0.005. And this will give me my common ratio, which I'm just going to do it on my phone's calculator. You know how to use a calculator. You don't need to see me do that. And then I get 0.5 as my common ratio. So this B value is 0.5. And then you just raise it to the power of x. That's an x. Oh my gosh, that's an x. Okay. And then this is your equation. Y is equal to 0.01 times 0.5 to the power of x. So the 0.01, that red number, is your starting value, and that comes from next to the 0 in your G table. 0.5, that's the common ratio, and that comes from picking any two numbers that are next to each other, dividing bottom divided by top, and you get your common ratio. And then let's type it in. 0.00 or 0.01 times 0.5 to the power of x. Last example for today is exponential regressions over 1. So it's a lot of words here. I'm just going to read it all now. The accompanying table shows the value of a car over time that was purchased for $20,600, where x is years and y is the value of the car in dollars. Write an exponential regression equation for the set of data, rounding all coefficients to the nearest hundredths. Using this equation, determine the value of the car to the nearest cent after 15 years. So I'm going to split my screen for this one because it makes it easier. It just does. All right, copy values for calculator, you click that button. Then you open statistics calculator, you click that button. I'm going to pull mine side by side so that you can see them. And then into my calculator, I'm going to paste values because I copied them, now I paste them. And then you go to the main menu. You don't want edit list anymore, you want calc menu. In your sub menu, you want exponential regression. Diagnostic can be on or off, it really doesn't matter. Calculate, and then you get this. So you will notice the format of the equation is right here. Y is equal to a times b to the power of x, just like we did in our last example. Actually, I'm going to make this one smaller. There we go. Okay, So I'm going to type that y is equal to a. I don't want to type the letter a. I'm just going to type this number. And I'm going to round it to the nearest hundredth, like it asked me to right here. Nearest hundredth. So that's 2 decimal places. So I'm going to copy the number 20241.6. Okay. There's a 1 here. And I'm going to look next to the 1 as a 0. 0 is a small number, so the 1 stays as a 1. So my a value is 20241.61, rounded to 2 decimal places. So that's my a value. Now I'm going to type times the b value. B value is 0. We want 2 decimal places. This is a 0.888. So after the second 8 is another 8. 8 is a big number, so this is going to be rounded to 0.89. And then to the power of x, because we have to type to the power of x. That's how the equation finishes off. So you must type your x as your exponent, because it's to the power of x. Just in case you forgot, you can type an exponent by pressing Shift and 6. Literally type this character on your keyboard and that will let you type an exponent. All right, so now that we got our equation, we have one more thing to do. We have to get our final answer. So what in the world is our final answer? Let me scroll up. Using this equation, determine the value of the car to the nearest cent after 15 years. So we want to know something after 15 years. That means we're going to be plugging in 15 as our x value. So let me go get my calculator. So we're going to be plugging in 15 as our x because it says after 15 years. So I'm going to copy this. I think you can copy and paste this. Paste. Okay, cool. So instead of the x, I'm going to type 15 because it's after 15 years. And then we're rounding this answer to the nearest, I cannot remember. Nearest cent. So nearest cent is 2 decimal places. So I'm going to round that number to the nearest cent. I'm going to write it out because you guys can definitely not see that in person. So this is 35244.80829. I just copied the whole thing. Rounding it to the nearest cent. So we want 2 decimal places after this 8 is a 0. 0 is a small number, so the 8 stays as an 8. So it's 3524.48. And that is it. Are there any questions for this one? And that's it. So I know there are more questions down here, the interpret dot plot, create dot box plot, all of that stuff. But remember, this is all included in the videos on my website already. So I'm not going to have to redo it for you. It's already there. You can do it on your own on this video. Also, we went over it like really recently, so it's a little bit less of a review. All right, so that's it for this video. I will upload this later on